All right, these notes are going to teach you how to simplify radicals before we evaluated them, which is using the use of your calculator. The calculator will not help you like you want it to with these. Simplifying means we need to break it down to a simpler model. So there are a couple different ways we can approach this, and there's a couple different things you have to know in order to do this correctly. All right, the first thing that's going to be noticeable is that you're going to have two different properties, one called the product property, the other one called the quotient property. All right, product means multiply, quotient means divide, so you can see how that's being used. For the product property, the square root of a product equals the product of the square roots of the factors. In other words, if you have square root of a times b, it will equal the square root of a times the square root of b. In other words, you're breaking down two numbers, right? So for the example that they've given you, the square root of 4 times 100 is going to be equivalent to the square root of 400, right? And the square root of 400 in your calculator will give you 20. Okay. For the quotient property, the square root of a quotient equals the quotient of the square roots of both the denominator and the numerator. In other words, when you have a large square root sign around a fraction, you must break it up into the square root of the numerator divided by the square root of the denominator. Right? So for example, with square root of 9 over 25, this is really going to break into the square root of 9 divided by the square root of 25. And then you do each one separately. The square root of 9 is 3, the square root of 25 is 5. So my simplified answer for that one will be 3/5. Right, so some of these answers will come out to be regular whole numbers or fractions that don't have a square root sign left in them. Other times they will remain a problem with the square root sign. Right? And just so you have future reference and point of vocabulary, the square root sign by itself is not officially known as the square root sign. The official name for it is the radical. Right? So when somebody says radical 5, they're really talking about square root of 5, right? And then underneath the radical sign is the number or letters, and that specific part is called the radicand. Right? You don't hear that one as much, but you definitely hear the radical. All right, so before we get started on any of these examples, I will be working out certain ones with you, and then the ones that I do not work out with you, you are responsible for working out on your own before class. All right, we do want to take down some information in order to successfully do the ones within the section that you have. So I'm going to use the space off to the right, right, to help write down some of these answers, and then we'll talk about how to do the problems once we get going with them. The first thing you're going to notice is that the directions are going to say simply to simplify, right, which means that you will have no decimals in your answer, right, which means the calculator will not be useful to you, right, because if you type in the square root of 3 in the calculator, right, you're going to get a decimal, and that is not a simplified answer. That's an evaluated answer. Right? So we want to look at answers that remain with the radical in them. Right? But before we do that, we need to know what makes something be in simplest form. So over here on the right-hand side, right, go ahead and write down these steps for me, right? And it helps you remember when you know you're done and when you know you're not done. So radicals are in simplest form if. And then you want to look for these 3 things. Okay. The first thing you want to look for, they are in simplest form if no perfect squares other than 1 are in the radicand. Which means if you have more perfect squares under that radical sign that you can take out, you are not officially in simplest form. All right, so the second one, you are in simplest form if there are no fractions in the radicand. And what that means is that you do not have a radical sign sitting over top of an entire fraction. You can have a radical sign in the numerator, right, but not over the entire fraction, or your fraction still needs to be simplified more. And the third piece that makes something be in simplest form is that no radicals appear in the denominator. You're allowed to have them in the numerator, but the denominator cannot have them. Right, so those are the 3 rules that you want to make sure that you're following so that you can get them into simplest form as quickly as possible. Now, in order to do these and do them well, right, you're going to have to remember and know your list of perfect squares. So the more you memorize them, the easier this is going to be. Right? If you don't memorize them, you will have to think through them every step of the way, and that will slow you down to the point where it may not be something that's useful for you. All right, so I am going to have you memorize the first 15 perfect squares, right, just so you can actually use them to get you going. All right, so I am going to write them up here at the top. You need to squeeze them in somewhere on your paper where you have the extra space, right? And we will do perfect cubes on the back once we get to that part. For right now, we're just dealing with perfect squares. 1 is a perfect square, and then we have 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 169, 196, and 225. That takes you through the first 15. If you need anything more than that, then you'll have to keep extending your list, but from my experiences, the first 15 are plenty. All right, so what we want to take a look at is what does it mean to simplify the problems that we have. All right, so again, I'm only going to work out certain ones with you, and then you're going to be responsible for trying the others on your own. All right, so do leave some white space around here for you to do the other ones, or use a separate sheet of paper to go back and try them once I'm done with the video. All right, so I am going to start with number 2. And the way I do these is like little trees. I always pick the perfect square number first, and then I branch it out. So if we have the square root of 50, the first thing you want to ask yourself is which one of those perfect squares in the top, except for a 1, because 1 goes into everybody, right? But out of all those other numbers, who divides into 50? And you want to find the largest one possible so you don't have to keep dividing more and more, right? And if you keep going, 25 goes into 50. So I make my branches, and I always put the perfect square number on the left-hand side, and you'll see why in a minute. So that's the square root of 25, and then 25 times 2 is what makes 50. So if I have the square root of 25 and the square root of 2, and then I put them back together, I will get the square root of 50, right? And here's where you want to simplify it a little further. The square root of 25 is actually 5. The square root of 2 cannot be simplified, so it just attaches right behind the 5. So your final answer is 5 square root of 2. Right, and that is what simplified radicals look like. There are no decimals, there's no equivalents, you're just basically simplifying by using perfect squares, and then whatever's left over stays in the radical sign. All right, so the next one let's go to is number 4. Right, you'll notice that in number 4, there's a number outside the radical, which is the same as saying 3 times the square root of 20. Right, well, the 3 does not break down, but we will use it later on. The 20 is what you've got to break apart using your perfect square list. So if I go ahead and set up my branches, right, and I find the perfect square that goes into 20, 4 is the only one that I've got, so it's the square root of 4 times the square root of 5. Right, so notice that the square root of 4 is 2. Square root of 5 stays square root of 5. But now you've got to bring that 3 back down. The 3 is on the outside, which means it multiplies times whatever else is on the outside. So I now have 3 times 2 square root of 5. Well, we want to combine these together. You never want to have more than one number outside the radical sign. So this final answer is 6 radical 5. Right? And that would be your simplified answer for your finished answer. Right, then go on down to number 6. Right? There is a negative sign, but notice it is on the outside. Negative signs will never appear under the radical sign because then you can't do them. Right? So for number 6, the negative sign will just keep traveling along once we split it apart, but we do have to break apart 108. Right? You can start at 4, and 4 most likely goes in. Okay, but there could be higher. So what we want to take a look and do is we want to start probably from the highest end, like near the 100 mark, and work our way backwards. Because if you work your way backwards, you'll find the highest one first before you find the lowest one. Because if you find the lowest one, you might have to break it down again. And I would hate for anybody to have to keep breaking down things that they didn't have to. Right? And you would find once you get your list going that 36 is the one that works. That's the highest one we've got. Right? So we have the square root of 36, and 36 times 3 is what's going to make 108. So this is square root of 36 and square root of 3. And keep that negative traveling along. Square root of 36 is 6. Put the negative sign in front, and then bring the square root of 3 down. Right? So this final answer is going to be negative 6 radical 3. Right, jump on down to number 8, and you'll notice that in number 8, it doesn't look like the rest of them. It's separated. Well, when it's separated, it means that the person who tried to break it apart didn't do their job very well, and you need to put it back together to see what they were supposed to have done in the first place. Right? So if we look at square root of 6 times the square root of 8, neither one of those are perfect squares, so that's your clue right there that they didn't break it down correctly. One of them has to be a perfect square, right? So when they're not perfect squares, we're going to join them back together, right? And then we'll break it apart the way we are supposed to. Square root of 6 times the square root of 8 is going to make the square root of 48. Okay, and now you want to break down the square root of 48. Well, 48, if you go back to your perfect square list, has a 16 in it. So we're going to take the square root of 16 times the square root of 3. And the square root of 16 is 4. The square root of 3 stays radical 3. So the final answer should be 4 radical 3. Right? But you wouldn't have gotten it using the 6 and the 8 the way they had set it up. Okay, so your job is to go back through that section and do all the ones that we didn't do together. Okay, and now let's go to example 2 and take a look at some more. You're going to notice that these involve the division property, or the quotient property, and then we'll take and do very similar to the multiplication property, but it looks a little different. All right, so let's go ahead and start with number 10. You'll notice that the top has a radical sign and the bottom does not, and that's okay, right? Because you're allowed to have a radical sign up top. What is not okay is the fact that the square root of 18 can be broken down more. So the way I usually set these up is I put the square root of 18 on top of the 3, but instead of the branches being underneath, I branch them out to the side. Okay, so if you go through your perfect squares list, 9 is the largest perfect square you'll get out of 18. So this is square root of 9 times the square root of 2. Right? And then if we simplify that, square root of 9 makes 3, and then radical 2, and then the bottom is still a 3. Well, you have to simplify your fraction. The 3 on the outside and the 3 underneath can cancel out because 3 divided by 3 makes 1. So your final answer to this one is just radical 2. Okay, you've got to simplify it as far as it can go. If you can reduce or you can divide the outside stuff, you've got to do so. All right, if you go to number 11, you'll notice that both numbers are under the radical sign, which means we've got to split this up. So we're going to make this into the square root of 80 over the square root of 45. Okay, and actually you can save yourself a lot of time. It will work if you take and break apart each one and you keep going from there, but there's a shortcut. When you have a fraction underneath the radical sign, such as the way it started, the very first thing you always want to check for is see if you can reduce. Because if you can reduce that fraction, you're going to save yourself a lot of headaches. All right, so I'm going to go back to where I started with the 80 and the 45, and I noticed that it ends in a 0 and a 5, which means 5 must be able to go in. So I'm going to go back and I'm going to reduce my fraction by dividing by 5. Okay, so if I divide by 5, I'm going to end up with 16 over 9. Okay, and that's going to mean that it's all under the radical sign still. So I haven't done anything other than reduce the fraction underneath. Now I'm going to split the fraction, my new fraction, up into square root of 16 over square root of 9. And you're going to notice that both of these are perfect squares, so your answer is going to come out so much nicer, so much quicker than if you had done it the other way. The square root of 16 is 4, the square root of 9 is 3, so your final answer is 4/3. Right? You still would have gotten it if you broke it down the 80 and the 45, it just would have been a lot messier. Okay, so if you can take a shorter way through the problems, then by all means, please do. Okay. Now if you turn your paper over, oh, and by the way, you will need to finish number 9 for that section. Go ahead and turn your paper over. We're going to do 13 and 14 together. Right? You're going to try number 12 on your own though. Okay, but for number 13, notice there's an 8 outside. So I want to take a look at what that means in terms of how you do the problem. Remember that means 8 times the square root of 3/4. Right? So when it looks like this, you can really think of it as 8 over 1. That way it looks like a numerator and a denominator, because where that 8 is in the numerator is where it's going to stay. When I go to break this apart, it's going to be 8 square root of 3 over square root of 4. And then I've got to clean this up because square root of 4 has more that I can do to it. Remember, you're not allowed to ever have a radical sign in the denominator, so that's how I know that I'm not finished, right? And then that leaves me with 8 square root of 3 over 2. Square root of 4 is 2, right? And I'm still not finished because the 8 on the 2 that you see outside the radical sign can divide and reduce. So after all of this, my final answer is going to be 4 radical 3. That is as simplified as that answer is going to get. Right? But you had to use the number on the outside correctly in order to get to the answer that we got to. All right, for number 14, here's another one of those. Actually, number 14, we're going to cross off what's there because we've already done something similar to that, and I want to give you a different problem to change into it. Please write in number 14's place the square root of 81 times the square root of 10 over the square root of 5. I want to show you when something looks like this how to deal with it, right? Because you do have a few that pop in that are going to resemble this, and if I don't show you them here, you're not going to know what to do with them, right? So the first thing we want to look at is, do you already have perfect squares? You don't want to put 81 and 10 together to make 810 if one of them is already a perfect square. The square root of 81 is going to make 9. So right now I have 9 radical 10 over radical 5. And there's nothing that goes into 10 and 5 in terms of breaking it down, but I'm not allowed to have a radical in the denominator. So something else has to happen to this problem. Remember back to your quotient property at the very beginning of this page. If each thing is under the radical sign and it can divide. You can technically divide them. So the radical square root of 10 divided by the square root of 5 is going to produce the square root of 2, and that 9 is going to stay outside. So the problem is not difficult. You just have to remember, if you have a square root sign on top and a square root sign on the bottom, you can divide those numbers and leave the product or the quotient part under the radical sign. Okay, so play around with those because there are little tricks and shortcuts you can take to help you through all of these. All right, so that's square roots. All right, then we want to go and take a look at the cube roots. Okay, and then I'm going to switch over to something that you've never ever seen before that may be a little far-fetched, but we'll talk about it when we get to it. For example 3, all of these are still simplifying, but notice that it's cube roots, not square roots, which means you cannot use that list of perfect squares. In order to do cube roots and simplify them, you have to use your list of perfect cubes. And just like we got the square list by doing 1 squared, 2 squared, 3 squared, 4 squared, etc., all right, perfect cubes are going to come from doing 1 cubed, 2 cubed, 3 cubed, 4 cubed, etc. I'm not going to have you go too high up. Usually after 6, you don't need to memorize anymore because you can use the calculator to test out if it's going to be or not, right? But I'll give you the first 6 and then we'll look at it from there. Right, 1 cubed, or 1 times 1 times 1 is 1. 1's a perfect everything. That's why he doesn't really count for anything. 2 times 2 times 2 is going to give you 8. 3 times 3 times 3 is going to give you 27. 4 times 4 times 4 is going to give you 64. 5 times 5 times 5 is 125. And 6 times 6 times 6 is going to give you 216. If you want to go higher in your list, you can, but you don't need to. Right. If we need to go higher than that, we'll use the calculator to help us out. All right, so you do this exactly the same way, except instead of breaking it down into perfect squares, you break your number down into perfect cubes. So I'm going to do 15, 18, and 20, and then you're going to try the rest on your own. All right, so for number 15, I've got the cube root of 56. You have to take one of those numbers from the list that we just created, and you cannot use the 1. 1's not allowed for anybody. You got to use something else. Right? So we need another perfect cube that goes into 56, and we need the largest one we can find. Right? Well, out of the two numbers that are smaller than 56, there's 8 and 27. One of them has to go into it in order to simplify it, and it's actually 8. So when you break these up, you break it into the cube root of 8 and the cube root of 7, because 8 times 7 is 56. And then you go back. The cube root of 8 is 2, the whole number 2, and then the cube root of 7 stays cube root of 7. And this is your final answer. So it does look a little different because it has the cube on the outside, and you're using a whole different list to get these answers. All right, then if we go to number 18, okay, you have the cube root of 1,000. Okay, now if you try to go and break this one down, all right, you don't have high enough numbers in this list. So when you get a big number like this, my first instinct for you to try is to go to the calculator and actually type in cube root of 1,000. Remember, the cube root button is located under the math button, right? And when you do that, sometimes it is already its own perfect cube. We get lucky every now and then, and 1,000 is one of those we get lucky on. If you type in the cube root of 1,000, your answer comes out perfectly to be 10. 10 times 10 times a 10 is 1,000, right? So you don't always end up with a radical sign in your answer, right? But when you do, you have to break them down correctly. All right, so if we go to number 20, we're looking at the cube root of 750. And that's also a huge number. And if you type that in, you would see that you would get a decimal. All right, so that tells you that there's got to be some other perfect cube going on here. Right? And if I take a look, because it ends in a 0, I want to try and use something that also has a 5 attached to it because they tend to be compatible with each other. So see if you can get 125 to divide into 750. All right, and it actually does. All right, so when we break this down, we end up with the cube root of 125 and then the cube root of 6. Right? 125 times 6 is what makes 750. We have 125 in our perfect cube list, right? So that's 5, and then cube root of 6 stays cube root of 6. Right? So this is as simplified as that one will go. All right, so go ahead and try the others in that section and see what you can come up with in terms of your perfect cubes. Okay, we will continue to practice with these in class as well. All right, the last topic, which is also the newest topic pertaining to these, other than the fact that you're breaking down square roots and cube roots, right, is the fact that under the radical sign will also be variables. And for some students, that's difficult to get their brain wrapped around. So I'm going to give you some pointers before we jump in and start doing them. And then I will help you with 3 of them and let you try the 4th one on your own. All right, so the first pointer I want to give to you is that you need to simplify the number first. Each one will have a number, a coefficient into it. So you need to simplify the number first, then the variables. Don't ever do it the other way around, right? Because you've got to break that number down. Your variables you're not really breaking down, you're just thinking about them differently. So you're going to do that first, and then the other thing you need to remember when it comes to the variables is for each group of x squared, you can take out an x. All right, so basically what this means is that the square root of x squared is an x. Right, it takes two of them before it comes out of the radical sign. I like to think about this like jail. Right, it is trapped in jail until it becomes free, and the only way it can become free is if it's got a group of two to take out. Right, so you'll hear me using that analogy over and over again as well. All right, so let's start with number 21. Okay, and I'm going to start with just the number part, the 32. So the square root of 32, I need to break that down first, and then we'll put all of it back together in terms of letters. Right, so the square root of 32, remember you got to go back to your perfect squares list. That's the list on the front side, the 1, 4, 9, etc. Okay, and I need to come up with the largest number that goes into 32. Now if you say 4, that is not the largest perfect square. It is a perfect square, but then you would have to break things down more because 4 and 8 are not the largest ones. If you keep going, you'll find that 16 is the largest perfect square. So this is square root of 16 and square root of 2. So when we go to write our final answer, you go ahead and write a radical sign, okay, and put your 4 on the outside, but leave some space behind the 4 because the letters that come out of jail are going to go behind the 4. The ones that stay in jail are going to stay in the radical sign behind the 2. But leave yourself that space so you can do this correctly. All right, remember, every group of 2, 1 comes out. Right, so if I look at my r's, I've got r squared. Well, r squared is a group of 2, which means an r comes out. Okay, no r's are in jail. Odd numbers produce letters that stay in jail. Even numbers produce numbers that come out. So then if I go to my k's, I have k to the 4th power. Well, that means I have 2 groups of 2. So that means 2 k's can come out, k squared. It's an even number, so nobody's still in jail. It takes 2 to break out. Right, but then when you go to your t's, the last letter, it's a 5, which means I can get 2 groups out, so t squared comes out, but because there is 5, I have 1 t that didn't have enough to get out, and he has to stay in jail with the 2. Right, so basically if you divide each exponent by 2, okay, the whole numbers come out, the decimals stay in. There will be some out and some in. So that's how you can tell. So if you have an odd number, you know it's going to be on the outside and the inside. If it's an even number, it will be strictly on the outside. All right, so let's try number 24. And then I'll let you practice with 22 and 23. All right, so for number 24, you want to break down the square root of 45 first. So your 9 and your 5 are going to be the 2 numbers that made 45 that used a perfect square. So square root of 9 and square root of 5. Okay, set up your radical. Not square root of 9 is 3, but leave some space behind it for the letters. 5 stays under the radical. All right, now let's deal with the letters. If I look at my k's, k to the 4th, all right, I can divide 4 by 2 and get 2. That means k squared comes out. Nobody's in because that's an even number. Then if I go to my b's, right, b squared, that's an even number. 2 divided by 2 is 1. That means 1b comes out. Right, there's none in because it was even. But then if I go to my c's, I have an odd number. 7 divided by 2 gives me 3.5, which means that the 3 in front of your 0.5 tells you how many c's come out, and that 0.5 means you still have a c left over inside. In other words, 3 groups of c's got out of jail, and there was still 1 guy who didn't because he wasn't a full group. All right, so I want you to try 22 and 23, all right, using the thinking that I just presented to you, and we'll see how well you adapt to it and whether there's more that I need to do.